Portuguese. Where he chairs the working group Spring. He has published several RFCs and has registered more than 60 patents in the United States. He's a member of the Internet Architecture Board and the Internet Research Steering Group and the Industry Network Technology Council. In addition to that, Alvaro belongs to our community. He comes from Costa Rica. So it is an honor and a pleasure to have him with us today. So I'd like to invite him now to make his presentation. The title is Reflections on the Future of Routing. Let's welcome him with a round of applause. Good morning. Good morning. Bom dia. I was happy when you answered in Portuguese, but that is as much as Portuguese as I can speak, so I won't torture you with my Portuguese. So let's go over to Spanish. A couple of weeks ago, I came across Carlos Martinez, and he told me he wouldn't be coming to, if I wouldn't come to LACNOC to speak about something. And I said, okay, I'll go and speak about routing. So let us reflect on the future of routing, because that is what I do. Precisely, I try to guess where we are heading. So what we agreed to was to speak about the future, where we're heading, and let us reflect together. I will therefore speak about how I reached the conclusion of what I think will be the future of routing. That's my opinion, and I'm sure there are things that won't be correct. Some might be wrong, but the interesting thing is that I think this is a process we'll be doing together. This photograph over here on the screen, if you see it from the side, is what the future of routing will be in the future. Thomas is surprised at this picture. And let me explain later on why or how I think this represents the future of routing. This is something that we can recall easily, this image, and we can then apply this as a reference of where we are heading. And when Carlos told me to speak about the future of routing, my initial response, well, I don't know. I don't know where we're heading. I know where we are, but I don't know where we are heading. That is why we agreed to speak about the ideas and the possible way of the direction in we are advancing. And that reminded me also of the first time that I became interested in routing. And I have been now working for quite a number of years in the development of the internet and on routing. The first time that I heard about the internet, I didn't even know they were speaking about the internet, and this was about 40 years ago. Many of you might not have even been born at the time. Who had been born 40 years ago? So it turns out that my uncle, my mother's brother, worked in the field of communications in Costa Rica. And I was at home in the living room, and this was back in the 80s. In the 80s, we had no computers. At least I didn't have a computer. We didn't have telephones. There was no internet. Maybe you had 4 television channels. You had to get up and change channels by hand. So the most thrilling thing was when someone came home and tell us something. My uncle used to travel a lot. He told us about his trips to Europe, to Spain, and the things he saw. And one day, he told us about a meeting at ISF, and this is myself listening to my uncle speaking. And my uncle told us about a system. I don't know if he used the word network, I just can't remember. If he had said the word net or network, I wouldn't have understood anything. So he told us about this system, and that this system would give us the opportunity of seeing what the climate was in another part of the world. Of course, there were no computers, there were no telephones, so the only way to know what the climate would be on the other side of the world was to dial a number and just pray that someone would pick up the line on the other end and to tell you, yes, it's hot in Sao Paulo. So for me, that was a revelation. Not to know about what the weather was like, but because of the implications it would have. Costa Rica, like many countries in Latin America, depends on tourism on one hand and agricultural production. Costa Rica exports fruit, pineapple, bananas, and is a coffee producer. So 15 years ago, I was in Brazil, and there was frost, so the coffee market was very favorable for Costa Rica. So when my uncle spoke about the climate, I said, well, that's amazing, because if I know what the climate is in some other part of the world, I can go and sell my coffee at a higher price. So the implications, the economic implications, the social implications of that system he spoke about were amazing for me. They were immense. And I said, well, how is that going to occur? Now, I imagined that this would be like a satellite or one of those things that they are hovering about the clouds, and they could report what was happening. Now, the big question for me at that time was, well, how does this manage to know that I am the person who wants to have that information and not my neighbor? Or that I want to know what the climate is like in Brazil, and my neighbor wants to know what the climate is like in some country in Europe, and not the climate. We want to know something else. So how can we convey that information to the proper location? And the only thing I knew about communications was about satellites. So how can I communicate with that satellite? So for me, that was the first time when I stopped to think about routing. How can I manage to take the information from here to wherever I am? And I never imagined that years later, everything was going to be in the palm of my hand. Not only the count, but also coffee, what the price of bananas is in any supermarket in the world, and where they come from. Much has happened since that day. When I heard about the internet, I didn't even know it was called the internet, but I told myself, that is what I want to work for, the type of activity. I didn't know what it was, I didn't know how it worked. I didn't know if this would ever exist one day, and not even in Costa Rica. But I told myself, that is what I would like to do, to work in that field. And for many reasons, work and the help of many people, I am working now in the development of the internet. And I managed to learn how information is sent from a satellite to my mobile phone or to any of your mobile phones. So this is what routing does. So at that time, there was no way for me to know what the future would be like. I didn't know what the future would be like at that time when I learned about that system. And when Carlos asked me the other day what would be the future of routing, I thought a bit, and I said, well, I don't know, but as we are all aware, the easiest way to try and reach what we want is what? Internet is faster, it's bigger, it's better, The requirements have changed. In the past, I only wanted to know what the climate would be like, what the weather was going to be like. Now I want to know everything. I want to be top quality, no interruptions, and that the information is available right now. If I take out my mobile phone and I click on Google and it takes more than 1 second, I'm worried about this. I say, what is happening with the Wi-Fi? So what is happening? So we all want everything. And right away. The network has increased. There are more services. There are more people, but there still are a couple of billion people that are not connected. But there is an amazingly high demand. So how can we foresee, how can we predict what will happen from now how can we know now what will happen within 15, 20 or more years? So the best way to predict the future is to create it precisely. This is something that Peter Drucker said. He's an economist from the United States. And what he said is that we cannot just sit back and see how things happen. You at network operators are aware that you have to be proactive. You have to update your configurations and the configurations of your networks in order to meet the requirements and demands of your customers, not only the ones they have today, but also the ones they will have in the future. So we have created in the community, routing systems, network systems that have been able to grow and evolve from practically nothing into global networks and to provide endless amounts of services and to support failures or changes in the type of use that have been amazing. As happened during the pandemic, overnight we left our offices and had to work from home. So the network, the way the network was used changed totally. But it continued to work. We continue delivering the packets to the proper destination. So if the best way to predict the future is to create it, the question is, where are we creating this future, the future of routing? I am fortunate to work in the ITF and to be part of the machine, of the process that develops the Internet standards. So I looked at what IETF was doing. These are the different areas where the IETF works.
Now, the important thing about these figures is that the work, the routing work, is about 1/3 of all the work that is done when developing our protocols of the Internet. It's more than 1/3. It's the area where we have about 20% of jobs and over 30% of the existing work. There are about from 60 to 80 new RFCs published every year on routing. There are stacks and stacks of papers, and there are many things going on. And of course, that means that routing is the most important thing in the world for everything. If you can't route, you can't provide values, you can't give packages, regardless of whether the communication is secure or not. So routing is not important, or the protocol we are using, or the app. Nothing matters. The most important thing, in my view, is being able to have a routing system that may last despite changes and grow and be secure, regardless of what future may bring. So far, this is what we've been able to do. It's a system that could evolve and grow. and without caring about the kind of applications that we have. Now, much of the work about the internet that the routing area does is divided into a number of working groups, most of the work is in protocols that we all know and that we use every day: BGP, OSPF, ISIS. Some use multicast. BGP is the largest group in IETF. So much so, it's so big that there's such a lot of work that we had to divide it into parts. So we have the part that works on RPKI, then BEST on services, and IDR that works with BGP itself. So, and that is the largest group in IETF. As a matter of fact, the group that does OSPF and ISIS, they rank among the 5 top groups, so most of the work is there. Now, the interesting thing, in my view, is that indeed there's a lot of work, but the question is, what are we doing? How are we creating that future? And if you look at it in the history of these protocols, in the early 90s, ISO, it wasn't IETF, ISO created the ISIS protocol and standardized it in, IETF standardized it in the 90s, but it wasn't until 2008 that there was a significant change in the protocol when they specified how to use it with IPv6. And that's almost 20 years ago. In the case of OSPF, the algorithms that are used are even older than the 80s, the 90s. The OSPF was defined in 1991. I'm quite old, and I hadn't started working there. And the one that OSPF version 3 that is the case is worked with IPv6. Well, that was developed in 1999. It was RFC 2740, and the most important, that is BGP v4, that was launched in 1994. And it was in 1998 that they defined the so-called multi-protocol in order to be able to use IPv6, among other things, with RFC 2283. So BGP has not changed in the last 30 years. So, of course, on the one hand, you have people saying that routing, there's nothing to add to it. And ever since the 90s, we haven't done anything, or at least nothing significant. There's a lot of work. I told you that over 30% of the work of IETF consists of routing, but what we are doing is hardening protocols, making them more flexible, safer, for them to grow more, thinking of convergence, because, of course, in the 90s, we started giving washer services in the internet, so it's no longer the same. If you look at the internet and it takes a couple of seconds, it's not the same as a telephone call. Well, as impatient humans, it takes us 250 milliseconds, so we have to converge. So working in convergence, a lot of work has been done, especially in internal protocols, improving fast reroute. And so that has had a great impact on network design. Now we all design networks with triangles. Look, if your network has triangles, that's a good network. If it has squares or circles, it's not so good because we want things to converge quickly. And so triangles are good, other things not so much so. So we've worked a lot on scalability. And why? Because we need to make the protocols grow, and as twice as much as they are now, because we still a great percentage of the world's population has no connection, so we need to be able to scale it up. We've invested a lot of time on security, RPKI, for instance. BGP v4 was defined in the 90s when everybody knew each other, so nobody was concerned about being injected a bad route. Nobody worried about security. Today, we're all worried about it. So we had to add RPKI. And you may realize that this is something external to BGP. BGP in itself has not changed for security, but it's an external system. So we've worked to make protocols faster, to converge faster, so that they may grow more, be more stable, and more secure. But the protocols themselves have not changed. They are the same. Some people now and then talk about BGP v5. When are we going to launch that? In my view, but this is my prediction, and I'm absolutely certain about it, that 99% of the odds that v5 will never grow, because we all use the version 4. So if we spend over 30 years to implement IPv6, how long would it take us to change everybody from PV4 to version 4 to version 5 of BGP? It would take us like 100 years. So the protocols won't change. We are going to have the same protocols. The other thing that we've done, and quite a lot, is using the protocols as a means to enable services. We've created many services, VPNs, for instance. We all have, well, many people. In ISPs, many people have different services. We can enable those services. And how do we do it? With a lot of signaling using the routing protocols. We've given the protocols a lot of information that is not routing, that we are not using to route. But as they are protocols that touch upon all the nodes in the network, we can tell everyone what's happening, including the development of VPNs on PS, for instance. All the protocols have extensions to take that information. And recently, with segment routing, all the protocols have changed to so that we can communicate segment routing, so that everybody will know what kind of behavior I can have in my router, but not to route. It's not used for routing. It's used for communicating the capacity, the ability that they have in the network. So we've used the protocols to enable services. An example here, I worked on RFC 9012, speaking of tunnels, BGP tunnels. There are BGP. Sometimes if I want to use a tunnel in some versions of BGP, of GSEC or whatever, I can communicate that I want to do that with BGP, and somebody in the other side of the router can create a tunnel. And that has nothing to do with routing, but it does have to do with enabling service. So it gives a secure to guarantee that the traffic is not intercepted. So we've worked a lot enabling services. What we've done then is much of that 30% of the internet has been creating a strong foundation, a strong basis, where where we are going to be able to build, and we're going to be able to build upon it. And that foundation will continue to evolve. It won't change. It will evolve rather. So it will continue to create services, opportunities over the network, depending on that base or foundation. Now, IETF routing, well, there are many things that happen, such as we're working with MPLS, this spring work, that is segment routing. Those are tunnels, encapsulations that we have in our network, and they're good to provide services. And with MTLS, we can, with segment routing using IPv6, we can encapsulate and address packets through the network. Now, this is an important thing because the routing protocols are not the ones that are addressing the packets, but rather the packet tells us what it wants to do. So we've changed a bit. We've changed the decisions of a distributed system to a system where each packet knows what they want to do. Now, how does the packet know? Well, they're told by someone, a controller of the network. Somebody tells them what to do, and the packet tells the network what to do. So the protocols, the traditional protocols, are used as a foundation, as a strong basis to where we can create those paths to pass these new services we have. And there's a set of protocols that IETF has done. Rift, ISVR for data centers, or Battle, the protocol of Ripple, that has a number of things. And the other is all the many protocols of Babel, of informal networks. So those are protocols that were designed for specific issues with topologies in mind. And so the protocol, for instance, Ripple depends on a tree, just as the protocols that were designed for a data center, they assume a tree. So it's very simple. I'm either going out, I step on it, or I go down. Very easy. And we could do that. We managed to do that. For instance, changing IPF. And as a matter of fact, there are some that use the traditional protocols. So those are specialized protocols. They won't change the way we route in because these are protocols with very specific purposes and jobs in the ecosystem. So what we did here was to create encapsulation opportunities and specialization. Remember when you see this picture, encapsulation and specialization.
There is another group, another working group, that is involved in trying to define services. And my favorite one is a new one that is called TVR, Time Variant Routing. So the idea here is to have satellite networks. If I have a satellite, and now we have the low orbit satellites, the LEOs that go by, and there are moments where I just don't see them and I can't use them. But there are other times where the satellite goes over my city and cannot deliver the traffic. But we know, if we know how the satellites move, we know when they can deliver traffic in a specific site. So we have a satellite that goes over Brazil and has traffic for Sao Paulo, but we know that it will be here in 5 minutes' time, for example. So we can tell the system that it has to deal with the traffic at that moment when it's here. So it's about informing the system what is going to happen with the topology in the future. So there are applications to preserve energy, more greener energies, in many parts of the world. There are outages on a regular basis. So we can say at 5 p.m., half of the network will crash because there will be no power. So preventively, we can reroute traffic to the existing links. So that routing does not change the protocols. It just tells us in the future that link won't exist, or that link will exist. And all the other procedures are exactly the same for BGP and all the rest. For all the other protocols, they're exactly the same. So what we're doing is enabling a new service. The CATS group, it's not cats, the animal, it's computer-aware transport system. So how can we route within our network? How can I guide this to a data center, knowing the load and the capacity that data center has in terms of computing and storage and whatever? It's a very interesting system, and it would be great, very interesting to do that. However, what we're doing is indicating what the loads are in the different locations and then wait for something to define the specific destination in order to use that data center. Now, what happens with all this? It turns out that traditional protocols only have one way to measure to do the metrics. There's only just one number to do this. So normally, once we create a network and you have an SPF in your network, so we have the bandwidth. There are people who normally configure the distance of the fiber and things of that kind in order to do the routing based on that. But that's just one thing. So what do we want today? Today I want to do routing based on time, based on the capacity of my data centers. I want to do routing based on the type of power I have, and I want to do routing based on the cheapest path, the greenest path. I want to do routing based on the application in order to provide a specific service. So those are just 5 things. There are many more things, and I want to optimize all these in the network. But the traditional protocols just have one type of metrics, just one number. So how can we optimize 5 different things, or maybe more? How can I make the fastest path also be the cheapest path, and to include the applications that require the highest bandwidth and the lowest delay? So this is a problem that we cannot solve. We cannot solve it with the protocols we have today. So what I need is a modern protocol, not a standard protocol that uses different metrics. It's the IGBP protocol. So but once again, we don't have these protocols, and it's the only one that has support for various metrics. So what we're trying to do here with all the other working groups is to enable services to provide indications regarding what is a type of service that I wish to have in my network. How do I want my packets to behave, to perform. So I am defending specific tracks. I need to use my infrastructure in order to define specific paths for each service so that they all are in the same place. The other working group is a very interesting working group, and people tend to forget it's a PCE group. PCE is the path computation element, and this is probably one of the most important groups, not in terms of value and volume, sorry, but the type of work it carries out, because what it does, it allows us to program the network. What we said earlier, namely, we have a Series 6 packet that includes the route within the packet. The path is included in the packet, and this is planned, it's programmed by a programmer. They do this using the PCE protocol. So it's one of the ways in which we can do this. So what is happening then? Traditional protocols are defining this strong basis on which we can build. We have several efforts that are done where we can enable services, and we have the capacity to program the network. Not only using PCE, but using other values, for example, YANG, which is used a lot to configure the network. Then there are other tools and protocols that we can also use. This PCE group has been very important, very interesting for me, because you are aware that things in life are like a pendulum. We think that something might be wonderful until it stops working, and then we are all working. And when ARPANET began many, many years ago, it turns out that the protocols were distributed until one day the network melted. There were many oscillations, the protocol couldn't support the changes in the links, and it just melted. Many people thought distributed protocols are not good, let's have centralized protocols. So implementations were done with centralized protocols, but we cannot see the details of what is happening, so we went back. And a couple of years ago, SDN was in fashion. The software-defined network, we have a controller that defines everything. It was then that we started working with PCE. The pendulum won't return to the other end. What I think is happening is that this pendulum has come to a stop. We are no longer at a time where we think that having something distributed is better, because we realized that we cannot distribute between all the computing between all the nodes in the network, the low latency computing or high bandwidth, deterministic delivery, the green paths and all the rest. We cannot do that. But we also realize that the centralized solution is not the option, because from a centralized position we can have a wide view of the network, but sometimes I cannot see the details fast enough. What happens if something crashes and I need to have immediate convergence in order to provide voice or video services or whatever I'm providing? I cannot wait until the controller realizes this. So we're now at a time in which we are right in the middle. We have networks. We are building networks that have distributed routing and at the same time are programmed. So what we have created is a pyramid. I would say you have studied Maslow's hierarchy of the needs. So what do we have? At the bottom we have connectivity, resiliency, scalability, We have protocols that provide this. They guarantee that the network will be there, that we'll be able to reach the other end, that there is a path, maybe not the best path, but there is a path to go from this point to any other point, or between whatever points you have out there. So we can guarantee that the information will reach that destination. Then we have a layer, and in this layer we can create services. We are aware of what is happening in my network. Maybe I can encapsulate traffic through that network in order to deliver the specialized services I wish to provide. And then we have the top layer, which is that of programmability. So I can program my network. I can define how I deliver these services, and I can also monitor this at the same time, as well as manage the network like I want. So I was saying earlier, the best way of defining the future is creating the future. What have we created? We have created a system that has a control loop that is closed. So it has a strong basis. We can do monitoring of the network. We can program the network at any moment. So what is happening, and is already happening, is that we have a network that is convergent in IP, and all the other encapsulations will start to disappear. And in my opinion, MPLS was a transition system between IPv4 and IPv6. MPLS from end to end is going to disappear. So these protocols, these traditional protocols, will guarantee connectivity, and we have the controller that views everything and programs everything in the network. The network will continue to evolve in this way. Now, I already spoke about the future, and I'm running out of time, and I didn't say anything about artificial intelligence. And quite obviously is what everyone speaks about when we speak about the future. The controller, which is the part that is going to define the paths, that already defines the path, the one that will strike the balance between fast paths and slow services, between performing in the network and save money in terms of energy. That controller is the one, and already has many cases using intelligence, artificial intelligence. It will collect the information, MPLS and so on. It can collect the information, it can use telemetry of the network, and can then not only use connectivity information, which is what the routing protocols do, but also use performance information of the network in order to define the paths proactively. Even to predict when something can change or when something can fail. So we're going to have different levels, and at the center we try to define that we have different levels of service within a network. So that is where artificial intelligence is going to be. We're going to be able to train, we're going to be able to make it learn about the performance of each individual network, because that is where the secret is. The protocols and the rest of the network has to use protocols that are useful to all of us, not to each individually, but to all. And of course for each individually. But this does not mean that it can meet all the requirements. So that is where the development will be in the future, in the controller. So to close, I said at the beginning that this image is what I thought would represent the future of routing. And what I see in this image is a very strong foundation which are the mountains. There is a very strong basis, a very strong foundation here. And this guy here, he doesn't see the foundation, not because there are clouds, but he's not interested in that. He just wants to have a service that allows him to go through that network, and that is controlled by the wind.
Wind is what controls. It knows everything is happening in my network, and not only can it send the principal at the beginning, but also it may reroute the service anytime in that network. It's going to be a very dynamic network. It will be a network where I continue to grow, where we are based on what we already have. I've run out of time, but I'd really like later, when the Lucknow event is over. I'm sure that many of you may have your own opinions, and I'd love to exchange ideas about this. Thank you.